Hey everyone, welcome back. Today, we're going to be taking a deep dive into the science of love.
Oh, fascinating.
We've got some excerpts from The Chemistry Between Us, Love, Sex, and the Science of Attraction.
Okay.
So get ready to uncover the biological forces behind those butterflies in your stomach.
It's amazing how we often think of love as this like intangible, magical feeling.
Right.
But really, there's a whole world of hormones and neurons working behind the scenes to orchestrate those emotions.
Yeah, the book actually starts with this really intriguing idea.
Okay.
For women, romantic love might actually be an evolutionary offshoot of maternal bonding.
Interesting.
Which makes you wonder, are those late-night texts and grand romantic gestures driven by logic
Right.
or by hormones?
It's a fascinating question.
Yeah.
And the book highlights this with a story of a med student who completely upends her life
Uh-huh.
after falling for a Vespa enthusiast at Burning Man.
What?
Yeah. She drops out of school to follow him to Fish concerts.
Oh, wow.
It's dedication, but is it rational? Yeah, I was going to say that doesn't sound very rational.
Or is her mummy circuit kicking into overdrive?
So what do you think is going on in the brain there?
Well, the book suggests that the same neural pathways that create a mother's deep love for her child might have been adapted over time to fuel romantic love.
So it's possible that the same biological mechanisms that drive a mother to protect her child are also pushing this woman to follow her newfound love across the country.
Yeah, it's certainly an intriguing possibility.
Yeah.
And to understand how these brain circuits work, let's look at a fascinating creature,
Okay.
the prairie vole.
Okay, yeah. I've heard of these little guys.
Mm.
They're like the poster children for monogamy in the animal kingdom.
Exactly. Prairie voles form these incredibly strong pair bonds, much like humans.
Wow.
What's so fascinating is that their close relatives, meadow voles,
Okay.
don't exhibit this behavior at all.
Really?
It's like a natural experiment in the evolution of monogamy.
So by studying these two closely related species, scientists can kind of pinpoint what makes one monogamous and the other not.
Precisely. And a key player in this story is oxytocin.
Oh, yeah.
You might have heard it called the love hormone.
Oh, yeah, oxytocin. Isn't it released during hugs and cuddling?
Yes. And it's also released during childbirth and breastfeeding,
Right.
further supporting that link to maternal bonding.
Uh-huh.
There was this groundbreaking experiment by Sue Carter
Oh,
showing that by injecting female prairie voles with oxytocin, it led them to form pair bonds,
wow.
even without mating.
Really?
This really revolutionized our understanding of how a single hormone can profoundly influence social behavior.
So it's not just about physical intimacy.
Right.
Oxytocin can actually trigger those feelings of attachment and bonding on its own.
That's what the research suggests.
Ah.
And there's more to the story.
Okay.
It's not just oxytocin working solo.
Right?
It's a whole team of brain chemicals, including dopamine and opioids, all interacting within the nucleus accumbens, which is part of the brain's reward system.
Wait, so are you saying falling in love is kind of like getting a hit of dopamine?
In a way, yes.
Like winning a prize or eating a delicious meal?
And it's this complex interplay that creates the rush of emotions
Right.
and the desire for closeness we associate with romantic love.
Okay.
But there's another crucial element, social memory.
Social memory. What's that got to do with love?
Think of it as your brain's ability to recognize and remember individuals.
Okay.
So for prairie voles, social memory is crucial.
Okay.
It allows them to distinguish their chosen mate from all the other voles in the colony.
Right.
Without it, they'd be mating with any vole that came along.
So in humans, is social memory what helps us recognize our partner in a crowded room?
Exactly.
Or remember those special little details about them that make them unique?
It's that ability to form lasting impressions.
Right.
And connect specific memories to individuals. And this brings us to the question of how these findings in voles translate to humans.
Right, because we're not exactly sniffing each other out to find a mate, right?
Well, hopefully not.
Yeah.
But it does make you wonder how these same chemicals are influencing our own romantic choices.
Right.
And one of the pioneers in studying the effects of oxytocin on human behavior is Marcus Heinrichs.
Okay.
And he actually faced a lot of skepticism initially.
Uh-huh.
People thought the idea that one hormone could influence something as complex as human behavior was too simplistic.
Yeah, the book mentioned he had a tough time getting funding for his research.
Right.
People were like, if this were true, someone in the U.S. would have already done it.
Exactly.
It's interesting how these big discoveries often come from challenging the status quo.
Absolutely.
Huh.
But Heinrichs was persistent.
Okay.
He developed a method to deliver oxytocin intranasally,
Oh, wow.
bypassing the blood-brain barrier.
Okay.
And this led to some pretty remarkable findings. For example, Beta Ditson's work showed that intranasal oxytocin actually had positive effects on communication and conflict resolution in real-life couples.
So a little sniff of oxytocin could be the secret to a happy relationship.
It's a thought.
That's interesting.
But the book also mentioned that these effects aren't universal.
Right.
It talked about how individual genetic variations can influence how we experience and express love.
So you're saying there's a genetic component to how we bond with others.
The research suggests that's a possibility.
Okay.
And one study in Israel found that women with a particular variant in the oxytocin receptor gene displayed less affection towards their partners
Wow.
and experienced more marital crises.
Interesting.
And what's even more intriguing is that this specific gene variant is similar to what you find in non-monogamous vole species.
Really? So like meadow voles.
Yeah. It makes you wonder if our genes might be influencing our relationship patterns in ways we don't even realize.
Okay, so we've talked a lot about oxytocin and female bonding, but where do men fit into this whole love equation?
Well, there's another key hormone at play,
Okay.
particularly in male bonding,
Mm-hmm.
vasopressin.
Vasopressin.
And to illustrate its evolutionary history,
Okay.
the book uses a rather extreme example,
Okay.
the anglerfish.
Anglerfish, aren't those the creepy deep-sea creatures with the glowing lures?
That's them. And the males are known for their extreme monogamy.
Wow.
We're talking about a level of commitment where they actually fuse themselves to the females.
So are you saying vasopressin is the like anglerfish hormone
Oh.
that keeps them permanently attached?
Not quite.
Okay.
But it does illustrate how evolution can shape mating strategies in fascinating ways.
Right.
In less extreme cases, vasopressin seems to play a key role in territorial behavior
Okay.
and mate guarding, ensuring males protect their chosen mate and offspring.
Wait, so is mate guarding like that jealousy you see in some relationships?
Well, there could be a connection there.
Okay.
For example, the book mentions this dramatic case of a man who was so enraged when his brother started dating his ex-fiancée
Oh, no.
that well, let's just say he took things to a whole new level of possessiveness.
Yikes. That's taking things a bit far.
Yeah.
But it makes you wonder if those feelings of possessiveness are rooted in some primal instinct to protect your mate,
Right.
even if it means resorting to less than ideal tactics.
It's a thought-provoking idea.
Yeah.
And it highlights that powerful influence of vasopressin.
So are you saying that guys are just naturally wired to be jealous and possessive thanks to vasopressin?
It's not that simple.
Okay.
But there is evidence that vasopressin plays a role in how men respond to perceived threats to their relationships.
So not all men are going to react that way, but vasopressin might be influencing those who do.
Exactly.
Interesting.
And it's not just about overt aggression.
Okay.
Vasopressin might also be involved in more subtle behaviors,
Like what?
like feeling threatened by a partner's success
Oh, okay.
or wanting to control their behavior.
So are you saying that understanding the role of vasopressin could help us understand why some men react the way they do in relationships?
That's a good way to put it.
Okay.
And it also highlights the importance of communication
Right.
and self-awareness in navigating those complex dynamics.
Okay, so we've got oxytocin driving those feelings of attachment and bonding,
Mm-hmm.
and vasopressin playing a role in mate guarding and territorial behavior.
Right.
But this all sounds very monogamous.
Right.
What about infidelity?
That's where the infidelity paradox comes in.
Okay.
Despite being wired for monogamy, infidelity is surprisingly common,
Oh, interesting.
even in species that form strong pair bonds, like our prairie vole friends.
Really?
It seems we have these competing drives,
Uh-huh.
the desire for stability and commitment,
Right.
and the urge for novelty and excitement.
The book used the example of marmosets.
Oh, right.
Their sexual activity just plummets after a few months of being together.
Yeah, it's like once the honeymoon phase is over,
Right.
they'd rather cuddle than,
Right.
It's a reminder that passion and desire naturally fluctuate over time,
Right, yeah.
even in bonded individuals. And there's another fascinating concept called the Coolidge effect.
What's that?
It basically states that novelty can reignite sexual desire,
Okay.
even in individuals who are already in a relationship.
So that explains why introducing a new individual to a group of marmosets suddenly sparks everyone's interest.
Precisely.
Interesting.
The Coolidge effect suggests this inherent tension between our desire for stability
Uh-huh.
and our craving for something new.
Right.
And research suggests there might even be a genetic component to infidelity.
Really?
Studies on female twins found that identical twins were more likely to cheat than fraternal twins.
Wow, so it's not just about morals or willpower.
Right.
Our biology might be pushing us towards seeking new partners, even if we're already committed to someone.
Yeah.
It makes you rethink the whole concept of monogamy.
It certainly adds a layer of complexity.
Yeah.
And it raises questions about the nature of love itself.
Speaking of which, if love is this complex mix of brain chemicals and evolutionary drives, could it be a form of addiction?
It's a fascinating perspective.
Yeah, the book explores this idea too.
There are these striking similarities in how our brains respond to love and how they respond to addictive drugs.
I remember the book mentioned a study where just looking at pictures of loved ones could reduce pain in people who are in new relationships.
Yeah.
And it activated the same brain regions as addictive drugs.
It's remarkable, isn't it?
Yeah.
It suggests that love can really be a powerful force,
Right.
both physically and emotionally.
But if love is like an addiction, does that mean heartbreak is like going through withdrawal?
There's research to support that idea.
Okay.
For example, George Koob studied a brain chemical called CRF,
Okay.
which seems to be involved in the negative feelings we experience with loss and separation, whether it's a romantic breakup
Right.
or the death of a loved one. And this brings us back to our prairie vole friends.
Okay.
When researchers separated bonded voles, they displayed signs of distress and even social deficits,
Wow.
almost like withdrawal symptoms.
So even prairie voles feel the pain of heartbreak.
Yeah.
It makes you wonder if the capacity to experience those intense emotions is what makes love so powerful, but also so potentially devastating.
It's a fascinating paradox, isn't it?
Yeah.
But despite its complexities and challenges,
Right.
love remains an integral part of the human experience.
Well, this has been an incredible deep dive into the science of love so far. We've gone from prairie voles to anglerfish,
That's right.
from brain chemicals to genetic predispositions, all in the pursuit of understanding this powerful emotion.
It's a fascinating journey.
Yeah.
And we're only just beginning to scratch the surface.
I can't wait to see what we uncover next.
Me too. It really is amazing how even these tiny creatures like prairie voles can help us understand our own human experiences.
Yeah, it is.
But there was one part of the book that really struck me.
What was that?
This idea of love as a kind of like an addiction.
Yeah, do you think it's accurate to compare love to an addiction?
Uh,
I mean, obviously it's not the same as like being addicted to a substance.
you're right. It's not a perfect analogy.
Yeah.
But there are these striking parallels in how our brains respond.
Right.
Think about like the intense cravings,
Yeah.
the euphoria of being with your loved one, and then those withdrawal-like symptoms when you're separated.
Right.
Like your brain gets hooked on that person.
Yeah, the book talked about those long-distance relationships
Right.
where people seem to thrive on the anticipation and the longing.
Yeah.
Could that be explained by the addiction model?
It's possible.
Okay.
The separation and the anticipation could actually heighten the reward
Right.
when they're finally reunited,
Okay.
kind of feeding that cycle of craving and satisfaction.
Yeah.
And on the flip side, it might explain why breakups can be so incredibly painful.
Yeah.
It's like your brain is going through withdrawal from its love drug.
It makes you wonder if understanding those neural mechanisms could help people cope with heartbreak more effectively.
Yeah, it's a fascinating area of research.
Yeah.
It highlights this powerful influence of our biology on our emotional lives.
Okay, so we've talked about like the positive side of those bonding hormones,
Right.
but the book also delves into some darker aspects
Yeah.
like jealousy and aggression.
Uh-huh.
It's a bit unsettling to think that these behaviors might also be tied to our biology.
It's important to remember that these hormones evolved to serve specific purposes.
Okay.
And sometimes those purposes involved,
Mm-hmm.
protecting your mate in your territory,
Right.
which could lead to aggression.
It's like that saying, all's fair in love and war.
Well, hopefully not.
Yeah.
But it does highlight like the intensity of those primal instincts, particularly when they're intertwined with those powerful emotions of love and jealousy.
The book mentioned a study where men given vasopressin were more likely to perceive neutral faces as hostile,
Right.
especially if those faces were male.
Yeah.
So it's almost like they're primed to see rivals everywhere.
It's as if their brains are on high alert,
Okay.
ready to defend their territory.
Right.
It's a reminder that these ancient neural circuits are still with us, even even in our modern world,
Right.
where we don't typically have to fight off competitors with clubs.
So how can we manage those instincts in a healthy way? Are
Right.
we destined to be slaves to our biology?
Of course not.
Okay.
We have this capacity for reason,
Right.
self-awareness, and empathy.
Okay.
Recognizing those biological influences is kind of the first step.
Right.
From there, we can learn to channel those energies more constructively.
It's important to remember that we have choices. It's not like we're just puppets
Right.
controlled by our hormones.
Exactly. But those hormones can exert a powerful influence.
Right.
Understanding that can help us navigate our relationships with more awareness and compassion.
So we've explored bonding, jealousy, and even the addictive nature of love.
Right.
What about when those bonds break down?
Right.
Infidelity is a topic that comes up a lot,
Yeah.
and the book calls it the infidelity paradox.
It is a paradox because despite being wired for monogamy,
Right.
infidelity is incredibly common,
Wow.
even in species like prairie voles
Right.
that form those strong pair bonds.
Uh-huh.
It challenges this notion that monogamy is purely a social or moral construct.
Okay.
It suggests there might be a deeper biological pull at play.
Yeah, the book mentioned a study on female twins
Yeah.
that found that identical twins were more likely to cheat than fraternal twins,
Right.
suggesting a genetic component to infidelity.
Right.
So is it possible that some people are just more predisposed to straying than others?
It's an intriguing finding, isn't it?
Yeah.
It highlights this complex interplay of nature and nurture
Right.
in shaping our behaviors.
Yeah.
We might have these biological predispositions,
Okay.
but ultimately we still have choices.
It's a bit like that old debate about free will versus determinism.
Mm-hmm.
Do we really have control over our actions,
Right.
or are we just playing out a script written by our genes?
I think it's a bit of both.
Okay.
We have these biological drives,
Right.
but we also have the capacity for reason and self-control.
Okay.
It's about finding that balance.
So how can we reconcile this biological drive for novelty
Right.
with our desire for committed relationships?
It's not easy.
Yeah.
The book suggests that monogamy isn't a passive state.
Okay.
It's an active choice
Right.
that requires effort, communication, and a willingness to work on the relationship.
Right, especially in a culture that often glorifies infidelity
Right.
and tells us that we're not truly living
Uh-huh.
unless we're constantly seeking new experiences.
It's almost like we're bombarded with mixed messages.
Right.
We're told to settle down and find the one.
Mm-hmm.
But we're also encouraged to keep our options open and never stop seeking excitement.
It's a difficult balance to strike.
It is.
Yeah.
But understanding the biological forces at play
Right.
can give us more agency in making those choices.
Okay.
It's about recognizing those urges without letting them control us.
Well, on that note, the book also dives into this fascinating
Yeah.
and sometimes controversial topic of sexual differences.
Mm-hmm.
It talks about how our brains are shaped by hormones and genetics from a
Right.
very early stage.
It's true.
Yeah.
The science is clear. There are biological differences
Okay.
between male and female brains.
The book gave this example of exposing female rat pups to testosterone,
Oh, wow.
and it actually masculinized their brains and behavior.
Right.
So are you saying that hormones can actually change the physical structure of the brain?
That's what the research suggests.
That's incredible.
And those changes can have a profound impact on behavior,
Okay.
including sexual behavior.
But does this mean our destinies are predetermined by our biology? Are
Mhm.
we just slaves to our hormones?
Not at all.
Okay.
But it does mean that understanding those biological influences is crucial
Okay.
for understanding the complexities of human behavior,
Right.
including things like gender identity and sexual orientation.
Right. And this is where things can get a bit sensitive. Some people
yeah.
argue that focusing on biological differences reinforces outdated gender stereotypes.
That's a valid concern.
Yeah.
And it's important to approach this topic with nuance and sensitivity.
Right.
We have to be careful not to use biology to justify discrimination or prejudice.
So how do we reconcile the science
Right.
with the social and cultural aspects of gender?
It is.
It feels like a delicate balancing act.
It is.
Yeah.
We can acknowledge the biological underpinnings of gender
Okay.
while also recognizing that that gender identity and expression are complex
Right.
and multifaceted,
Mm-hmm.
and individuals can experience and express their gender in a wide variety of ways.
So it's not about denying the science,
Right.
but about understanding it within a broader context?
Exactly. It's about embracing the complexity of human experience,
Okay.
recognizing that both biology and culture play a role in shaping who we are.
Well, we've covered a lot of ground today.
Yeah, we have.
From the prairie voles to those anglerfish, from the rush of new love to the heartache of heartbreak.
Mm-hmm.
It's amazing how much we can learn about ourselves
Right.
by studying the animal kingdom and the intricate workings of our brains.
It really does make you appreciate the interconnectedness
Yeah.
of all living things.
Yeah.
And it highlights the fact that even the most profound human experiences
Mhm.
have a basis in biology.
But knowing that love has a biological basis
Right.
doesn't make it any less real or meaningful.
Right.
It's just a different lens through which to view this complex
Mhm.
and powerful emotion. It's fascinating, isn't it?
It is.
We spend so much time thinking about love and relationships,
Right.
but we rarely consider the biological processes like happening beneath the surface.
Like we've been trying to understand this complex machine without looking at the engine.
Right.
And now the tools of science,
Yeah.
we're starting to see those inner workings.
So where do we go from here? How does this knowledge like change how we approach love and relationships?
Well, that's the $1,000,000 question.
Right.
This new understanding of the brain is both exciting and a little bit daunting. It challenges those traditional romantic notions that love conquers all,
Right.
or that we're all destined to find our soulmate.
So are you saying that we need to throw out those romantic ideals altogether?
Not necessarily,
Okay.
but we might need to refine them,
Okay.
to integrate this scientific understanding with our emotional experiences.
Right.
It's about finding a balance
Okay.
between the biology and the poetry, so to speak.
You know, the book ends on this note of rewriting the story of love.
Right.
It's like we're at a turning point where we can create a new narrative
I love that idea.
that incorporates both the scientific and the romantic.
It's about recognizing that love is complex,
right.
that it's influenced by our biology, our upbringing, our experiences, and that understanding can empower us to make more conscious choices
Right.
in our relationship.
So instead of just falling head over heels in love and hoping for the best, we can actually use this knowledge to navigate those ups and downs effectively.
It's about understanding those early warning signs.
Okay.
Those patterns of behavior that might be driven by those ancient neural circuits,
Right.
and finding ways to communicate compromise.
This all makes me think about the bigger picture too.
All right.
How might this knowledge like shape our social policies
Right.
or even our approach to things like couples therapy?
Those are great questions.
Yeah.
Could understanding the biological underpinnings of infidelity
Yeah.
lead to more compassionate interventions for couples
Right.
struggling with betrayal?
Okay.
Or could this knowledge help us create educational programs
Right.
that teach young people about the complexities of love and relationships in a more informed way?
It's exciting to think about the possibilities.
It is.
But there's also a potential downside.
Yeah.
The book touched on this idea of love potions
Mm-hmm.
and how people have been trying to manipulate love for centuries.
Uh-huh.
Could this knowledge be misused?
It's a valid concern.
Yeah.
Just like any scientific discovery,
Right.
there's the potential for misuse.
Okay.
Imagine a world where pharmaceuticals could enhance or diminish
Wow.
those love hormones.
Right.
Where you could take a pill to fall in love,
Wow.
or to get over a breakup.
That sounds like something out of a science fiction movie.
It does make you wonder about the ethical implication.
Right. Yeah.
Absolutely. As we delve deeper into the science of love, we need to have those ethical conversations alongside those scientific discoveries.
Right.
It's about ensuring that this knowledge is used responsibly,
Right.
to enhance understanding and well-being,
Okay.
not to control or manipulate others.
So it's not just about the science itself. Right.
It's about how we use it.
Exactly. And it's a conversation that needs to involve scientists, ethicists,
Right.
policymakers,
Right.
and everyday people like you.
Well, this has been an incredibly insightful deep dive into the science of love, attraction, and bonding.
It has been fascinating.
We've learned about the fascinating ways our brains are wired for connection.
Yeah.
The hormones that drive our desires,
Right.
and this complex dance between nature and nurture that shapes our love lives.
And while this journey might have challenged some of your preconceived notions about love,
Yeah.
remember that it's still a powerful and essential part of the human experience.
It's not about taking away the mystery or the magic.
Right.
It's about adding a layer of understanding, a
Exactly.
new dimension to appreciate.
So as you go about your day, think about those subtle biological forces at play
Mm-hmm.
in your own life and relationships.
Right.
And remember, love is a journey, not a destination. That's a great way to put it.
Thanks for joining us
Thank you.
on this deep dive into the science of love.
We'll see you next time for another fascinating exploration of the world around us.